Well, can you guys hear me? Well, hello guys. Am I audible? Hello guys. Yes. So welcome to another episode of Current Electricity. This we've been having a great session till now. It's been 4 classes, so we'll continue with this today. So before we go further, I would like to tell one thing: keep your distance. Stay at home. Stay safe. It's a very tough time for everyone in the world, not just you guys. It's tough for you, me, for the guys on the island here who are swimming with the island. So I know at this time of Corona, I want all of you guys to stay at home, maintain minimal contact with everyone, keep your distance, all right, and wash your hands regularly. So yeah, while you're sitting at home, staying safe, crack IIT-JEE with India's largest platform, which is Unacademy. All right, get the Plus subscription using the code NSS1 to access unlimited live and recorded courses from India's best educators. Okay, best educators सब है एक ही जगह पे, or you can watch it all of them while you're at your home with your phone or with your laptop. So this is how the app will look. Install the app right away. We have the daily quiz show happening today at 8:30 p.m. All right, थोड़ा time change कर दिए. We will have the daily quiz show today at 8:30 p.m. All right, this is the program. I guess we're back. Yes, so hola amigos, I am N Srikant. I did my BTech from IIT Kharagpur. I have an AIR of 385. I've been guiding young minds like you guys for the last 5 years. You guys call me human calculator. Let's see why. And I'm a Sunrisers fan. अभी अच्छी time नहीं है, but then let's see. Getting pretty interesting. And DC is equally marvelous, if not better. Yes, I'm a Joker ka fan. I feel DC is better than Marvel. If you have anything to say, just hit the comment section below. And don't forget to like the video. All right, just like the video and make this viral. Hello, Sairam Garu. Hello, Amma. So this is the program I've launched for you on YouTube. This is called Ad Astra. It is aim for the stars and crack IIT-JEE. So along with Unacademy, aim for the stars and crack IIT-JEE. So generally, anything the main focus for cracking IIT-JEE should not be about the exam. It should be about understanding, analyzing things. Okay, so let's do a lot of analysis today also. So this today's topic is current electricity. We are doing the fifth day for today is the fifth day of analysis of current electricity. मतलब इसमें let me tell you one thing for sure. Before we go further, how to understand potential difference. This diagram is the proper encapsulation of everything that involves potential differences. So जो भी positive, this side is positive charge and this side is negative charge. And whenever current flows from negative to positive, it is taking a jump. And resistances will always reduce current. Resistance is like water flow. It will make water flow like this. Same way it will make current flow like this. From higher potential to lower potential. Alright. So whenever you cross a current passing through a resistor, you just write minus. And whenever you go from negative to positive terminal, it is always a height change. Be it a capacitor. Yeah, positive negative. If you're going like this in capacitor, suppose your potential is V, here it will be V plus something else, Q by C. Something. Understood? So this is very important. I hope you guys understand the importance of like how to take the main convention. काफी tricky होता है. So we'll discuss about sign convention again. This is my method. So the sign convention, imagine potential to be level on the ground and current is water. You take one level as zero, then you're taking an elevator like this. You're going up using an elevator, then you're sliding down. It's like a kids playing. It's a kids playground, as one of my friends said. All right, it's a kids playground here, so play along with it. All right. So exponential, so equipotential surfaces. So there are main things I want you guys to understand is how to find out equipotential surfaces. So right now, as we discussed here, we have different potentials everywhere, and this entire thing where there is nothing, this kind of surface is equipotential. Suppose there is one resistance, and then you come back to the same level, and then go up and come back to the same level. These both are having same potential, right? If you observe, suppose there's a sudden height and then there's a sudden bump like this. You're going to Tirumala. All of you have, I'm pretty sure a lot of you have gone to Tirumala. Like Tirumala is some plateau in between mountains. The mountains are higher, but this place is a plateau. So here there will be equipotential level. Getting it? This kind of level where there will be at same potential will be called equipotential surfaces. So the main concept of equipotential is that equipotential surfaces, if you understand, you can link them to be the same point. You can link equipotential surfaces to be to the same junction, to the same point. So this is a very useful technique. So for that we have to certainly identify some symmetry. We have to redraw the circuit and reduce the circuit. There are many ways of identifying symmetry. All right. तो मतलब थोड़ा बहुत हम ऐसे ही जाते जाते let's find out. Let's take a circuit like this. कुछ इस टाइप का सर्क्यूट है. तो इस सर्क्यूट में it is symmetric about this particular level. If you observe carefully, this is the opening end, this is the closing end. You have to identify it by identifying symmetry like this. Like here there will be symmetry. Understood? यहाँ पे about this line there will be the left side and right side are symmetric. So you can identify symmetry in many ways like this. कुछ और भी ले लो. ऐसे अगर इस टाइप का ले लिए तो what is the symmetry about? It is again symmetric about this level. If you observe, it's symmetric about this level, also about this. It is symmetric about this and also about this. So there are multiple layers of this is the layer of symmetry if you observe. So इस टाइप का there are many ways of dividing based on looking at it. If all the resistances are identical, then you can break it down by using symmetry. Okay. So then you can use the symmetry and redraw the circuit. और उसके बाद then finally you can reduce the circuit into simpler methods. As today we will discuss about a lot about equipotential surfaces and how to reduce circuits. All right. So there we go. तो पहले इस क्वेश्चन में हम सिमेट्री का यूज करने we will use symmetry in this question. So yesterday's quiz, hello Sim24, yesterday's quiz I forgot to put it on the laptop, so it didn't get published. So I think I have to publish multiple quizzes at one go. That is the better way. So I've changed the quiz today to 8:30 p.m. All right, the quiz today is at 8:30 p.m. So do come at 8:30 p.m. today. Let's see how the people are at 8:30. Okay, so that is it. I've already published the quiz today, so we have no doubts. We are definitely going to have a class at 8:30. Okay. So let's take a simple question. Yesterday we discussed about across AG using symmetry. Today we will try to observe this particular equation using symmetry. We'll try to find out the effective resistance across this using symmetry. All right. So इसमें पहले यहाँ से करंट कैसा फ्लो होगा. You have to analyze about how current is flowing through all these ends. Okay. So across this, if you observe by symmetry, you can say this current and this current will be same, because it has to eventually reach this and both of them are perpendicular to this. If you observe carefully, the direction of current to AD and AE is perpendicular to AB, right? The current direction of AD and AE is perpendicular to AB and they have similar structure. If you look towards B, if you go from D, it can go from CB, from E it can go from F to B. So they have a similar structure. Yes, exactly. So you're getting it. So यहाँ पे E और D are equipotential surfaces. So first identify equipotential places. Identify equipotential surfaces. One thing we know, E and D are equipotential. All right, we know E and D are equipotential. And what is the other thing we know which is equipotential? The current coming towards B. So F and C, from here only currents will come. So F and C are also equipotential surfaces. Are you getting it? F and C are equipotential surfaces. E and D are equipotential surfaces. So what are left? H and G. If you observe H and G, H is closer to A and G is closer to B. So will there be symmetry between H and G? There could be symmetry exactly in the middle of H and G, but in the middle of H and G there is a wire. So H and G are not symmetric. So ये याद रख लेना, H and G are not symmetric because the 2 points are not symmetric with respect to A or B. A से अगर ED को देखोगे तो they both are right beside it. Or F and C, if you see, they're right beside B, other than A, which is already there. So these both have same symmetry, you can understand. But H and G, if you observe, G is closer to B, H is closer to A. So they are not symmetric about A or B. ठीक है, ये बात याद रखना, are not symmetric about A or B. तो हमेशा A और B, the initial point or final point के across you have to check for symmetry. All right, check for symmetry about. So identify symmetry. तो इसको, so now I'll explain it clearly here, saying, okay, we'll come to that after this is done. All right, तो पहले इसको finish करते हैं. H and G are not symmetric, and we also know that A and B are the 2 points. So अब A across B, तो हम A यहाँ पे लिख देते हैं. Let's write B here. तो हम क्या करेंगे? Let's take A and B to be here. They are connected by resistance. All right. तो E and F को एक पॉइंट कर दिए. E and D को, E और D को एक पॉइंट कर दिए, and then F and C we made of 1 point. Okay. So from A we have two resistances to E and to D. All right. From F to C we have two resistances from B to F and C. And what about E to F? We have one resistance from E to F. We have one resistance from D to C. Are they the only thing? E to C direct nahi hai, and D to F भी direct nahi hai. And what about H and G? H and G have one resistance to E and F, E and D. तो H and G का भी अगर देखा जाए तो we need a bigger diagram than this. Just draw it again. I'll draw it right beside. थोड़ा नीचे से भी. AB, we have ED here, and we have FC here. So A to B there is one resistance, and from A to ED there are two, from FC to B there are two, and between each other there are two resistances. So E to F एक है और D to C एक है, and then from E to H there is one, D to C there is one, D to H there is one. So if you take H and G separately, H to C there is one resistance here, and then there is from E to H and D to H, and again from G to F and G to C. So this is how this whole thing is looking. Beautiful, है ना? So if you look at it, Ramesh, those things are not for me to discuss. All right, so this I want to discuss only about symmetry. This is the main point. You have to understand. I hope you understood. E and D are symmetric. Similarly, F and C are symmetric. All right, these both are non-symmetric points. So these both together I can join and solve. These both also I'm joining and I'm solving. If I join both of them, एक बार ऐसे करके क्रैम्प कर दो, दोनों को join कर दो. If you join both of them, this is how it will look. You touch both of them across one edge. This is how it will look. You in fact try it. You'll find exactly like this. So this is the effective thing. So now let's solve this. Okay. Solve this question again. तो इसमें क्या हो गया, ये आ गया. तो लेट्स ड्रॉ दिस डायग्राम अगेन. देयर इज R here, 2 R's 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 here, and an R here. तो effectively अब ये कितना हो जाएगा? ये R/2 हो गया, ये R/2 हो गया. This is R, and this is also R/2, R/2, R/2. So let's solve it now. This is R/2, this is R/2 and R/2, and this whole thing is in parallel with 2R. That's okay. Now these both are in parallel. First, the effective resistance of this will be 2 by R plus 1 by 2R whole inverse, which is equal to how much? So we can also say M1 M2 by R1 R2 by R1 plus R2, which is R square by R1 plus R2, 5R by 2. which is 2R by 5. So this became 2R by 5. This is called simplifying it and converting into this. Yes, exactly, sim 24. R by 2, R by 2, 2R by 5 will become how much? Now the whole thing will become R plus 2R by 5. This will become 7R by 5 and this will become R. So the effective resistance will be 7R by 12, which is the option. Understood? So I hope this is adequately clear to you guys. कि बस एक बार सिमेट्री से 2 पॉइंट्स आ गए तो then the story will change. Today we are going to do loads of symmetry problems. Every symmetry will be, we'll cover all kinds of symmetries. All right, so stay tuned, relax and have fun. So पहले identify symmetry. So you have to identify symmetry based on the original, initial and final points. So across the initial and final only you have to find. Like in this previous question, तो यहाँ पे initial एक है, मान लो कुछ ऐसा है. We know one thing, it is symmetric about these both. So this will, whatever current here it is flowing will be same here, and this point will be symmetric points. Similarly, this and this point will also be symmetric points. Getting it? So if you put a resistance across this also, there won't be any current because they both are symmetric. So these kind of logics will happen a lot. So when you take symmetry about initial and final points, you can always remove this kind of resistances. So the resistances across similar potential can be removed. मतलब ये दोनों को across यहाँ पे, मगर just like in this previous question, suppose there is a resistance between F and D. Like there is a resistance between E and D. Like E and D are identical potential, right? Yeah, if there are like two resistance between E and D, like in this case, suppose there is a resistance here. तो इसको हम आराम से निकाल सकते हैं because of symmetry. Are you getting the point? This is what is the major crux of the situation is that whichever resistance is across symmetric points, इसमें क्या draw करोगे? You will draw, if you have to draw resistance here, you will draw it like this. So this is one resistance. So इसमें same point तक आने के लिए will current flow here, I will be equal to 0. Getting it? So that is what happens here also. Then redraw the circuit accordingly. Suppose this is the most complicated circuit, then you can remove these both, and since these both are equal, and one more thing we know here, whatever current flows here will go out through this. Okay, so one thing you can understand, you can remove these two resistances and इसको क्या बना सकते हो? ऐसे बना सकते हो. So one thing I know, the current here and here will be same. Similarly, current here and here will be same, and now current here and here also will be same, and here also will be same. So redraw the circuit. इसमें काफी techniques है. We will discuss about lot of techniques. A few of them I will mention here. To redraw the circuit, one thing is you can join equipotential points. Potential points. Second point is you can also remove two equipotential points. What if we put a wire perpendicular to 1? What is 1 here? In this. The equipotential points, if if you remove one, yeah, you can remove both of them. You can remove both of them. Like there is nothing, no one here, man. I don't know what you're talking. You can join equipotential points. You can also remove or break an equipotential asymmetric point. So what I mean to say is, यहाँ पे अगर ये दोनों, जैसे यहाँ पे इसी एग्जांपल में फिर से देखते हैं, लेट्स इरेज दिस एंड आई ड्रॉ दिस. तो मान लो लेट्स टेक ए स्मॉल सर्क्यूट लाइक दिस. यहाँ पे एक ऐसा है, एक ऐसा है, एक ऐसा है, एक ऐसा. And similarly, same thing will happen here. Suppose this is how symmetry is working. So one thing we know, the same current whichever is flowing here will flow here, and same current which comes here will go here, right? So यहाँ पे there is no exchange of current at all. So यहाँ पे जो करंट जो हो रहा है वो तुरंत बाउंस बैक, इट्स बाउंसिंग बैक immediately. The same current here is also bouncing back in its own direction. So you can also remove this point and you can also make this like ऐसे करके you can make them each of them to have same, and similarly you can break this lower point also. तो अगर ये दोनों joined है तो you can also remove this joint. You can remove this joint. So that is what we are saying. There are a lot of techniques like that with which you can reduce the circuit and make it much easier to calculate. All right. So this is the solution, guys. We simplified this into this kind of circuit, and from there we just divided it. Okay, next. Perpendicular to the line of symmetry, every resistance is perpendicular to the line of symmetry. You can remove resistances. This is a very important point. Perpendicular to line of symmetry. So in this case, यहाँ अगर देखा जाए तो this is the line of symmetry. No, you're taking from A to B. You can clearly see this whole thing is symmetric about this line. ऊपर जो है नीचे जो है, they both are same. In this case, you can remove resistances perpendicular to line. तो इस एग्जाम्पल में देखा जाए, if every resistances are, तो you can remove these both because there won't be any current flowing through this. पहले symmetry से क्या we know, from here and from here there will be same I/3 current flowing, right? There will be one third current flowing through all three sides. So at this point and this point and this point the potential will be same, hence there won't be any current flowing through this. So remove resistances perpendicular to the line. So this can also be drawn as तो ऐसे करके you can draw them, you can remove both these resistances. अब ये ऐसा हो गया R each, तो effective resistance सीधा आ जाएगा, it will become a much simpler circuit. Now you can reduce it, saying 2R and 2R, तो effective resistance हो गया 2R/3. समझ में आया? So this is one wonderful technique which we can always apply whenever the circuit looks complicated. Find out the line of symmetry, about which line it is symmetric. Current flowing in and flowing out should be symmetric about a particular line. All right. और उस लाइन के परपेंडिकुलर जो भी रेजिस्टेंसेस है उनको you can remove. Got it? So this is one wonderful explanation, guys. All right. So if you like any of this, just like the video and share this video. All right. यहाँ पे ये 2R है, ठीक है, ये 2R है. So the question थोड़ा change हो गया बच्चों. This is not the question. We have to make this 2Rs. All of them are 2Rs. These are 2Rs, and the options में everywhere you will get 4R. ऑप्शंस को थोड़ा चेंज कर दूंगा मैं, सो जस्ट गिव मी वन मोमेंट. तो ये क्वेश्चन को सिमेट्री से करने को ट्राई करो. गिव मी वन मोमेंट गाइस. ये सब 2R है. दिस इज 2R एंड दिस इज ऑल्सो 2R. and 2R. So to find the effective resistance across the entire thing, the values are there you go. So try solving this by symmetry because this is symmetric circuit. अब यहाँ पे देखो तो this is also R, by the way. Yes, that is the correct answer. It's very simple, but symmetry से 1 second में हो जाता है. This question will happen within 1 minute by symmetry. So if you observe carefully, this thing is symmetric about this axis, no? ऊपर जो भी है नीचे same है. So anything perpendicular to this can be removed. So this one and this one I will be removing. You can remove both of these. Hence, what will I be left with now? Once I'm done with removing symmetry, now I can reduce the circuit. What did I say? Once I identify symmetry, I will redraw. I will redraw the circuit. Once I identify symmetry, I will redraw the circuit like this. अब ये कैसा है? 2R है, 2R है, यहाँ पे 2R है, और यहाँ पे 2R है, और यहाँ पे भी 2R है. So this is two resistances. So let me just draw them. So this is how it is. So now we can just solve this right away. No, it will become like 4R parallel to 2R parallel to 4R. 4R, 2R and 2R parallel में तो ये केस कितना हो जाएगा? It will automatically become like this. This is 2R and this is 2R. So effective resistance will be 2RR by 2RR by 2RR by R plus R. तो इसका effective resistance R1 R2 by R1 plus R2 ना, 4RR by 2R plus 2R हो गया 2RR by R. So this is the option, guys. So एक symmetry से you can directly cut or condense the whole situation into a very simple equation just by single symmetry. All right. तो अब इस क्वेश्चन में देखते हैं. We will identify the resistance across AB. तो इसमें I will give you just like half minute time before I start solving. और एक बार टाइमर भी देखा जाए. एक बार टाइमर को लेके आते हैं. All right, the timer is here. I'm going to give you 1 minute. Good one, Sim24. That was very quick. Let's see if you can do it within 1 minute. So this question may we have to use symmetry like in the previous case. तो इस क्वेश्चन में मैं एक्सप्लेन कर दूंगा. I will explain it to you guys. So what happens यहाँ पे? So I will again use the original logic of what I used. यहाँ पे जो भी current है जाएगा. So one thing we know, whichever current goes up here will come down from here, right? And whichever current is going through this will come through this again, right? So hamesha whenever that happens, similarly the same current is flowing through this again. So this side the current which is flowing here is same, which means you can neglect this resistance as well as this resistance, guys. समझ में आ रहा है? This is a very cool description, because whatever current is flowing here, the same current will flow through this, and whatever I1 is flowing through, that same current will flow through this side also by symmetry. If you look from A and B, whichever current is flowing here will come here, whichever current is going up there will come here by symmetry only, right? So इससे हमें क्या पता चलेगा? There won't be any current flowing through these both resistors. So now we can redraw the circuit. ये चारों series में हो जाएंगे. If you remove this, there will be 4 in series. With the 4 in series together, that will be in parallel with this. तो इस पूरा इक्वेशन को हम ऐसे कंडेंस करके लिख सकते हैं. यहाँ पे 4R है और this both also will join together because there is no extra current here, and followed by R here and followed by 2R यहाँ पे. So this is the kind of circuit we will be getting, guys. ये this big circuit can be compressed into this simple circuit. Alright, that is the beauty of it. Once you compress this small circuit, now calculating equal resistance across these both first. क्या हो गया रे? All right. So is it clear? So we got this. Now we will start simplifying this equation. 4R and 2R. The effective resistance will be R1 R2 by R1 plus R2. So I will simplify this as this is an R. This is also an R. This is 2R. And this one will be R1 R2 by R1 plus R2. तो हो गया ये 4R by 3. And the whole equation becomes now this is 2R and this whole equation will become R plus 4R by 3, which is 10R by 3. So effective resistance कितना हुआ R1 R2 by R1 plus R2. So 20R by 3 by 2 plus by 16 by 3. तो ये कितना हुआ 5R by 4. Right answer. Alright, so this is the solution, guys. And one more thing I want you guys to understand: whenever you have two resistances in parallel, the effective resistance will be definitely less than both of them. तो यहाँ सीधा ऑप्शन 3R को निकाल सकते हैं, नेगेट कर सकते हैं, because it is smaller than, it is bigger than this resistance 2R. ठीक है, तो this way we can also nullify certain options and understand symmetry by the way how current is going to go. All right, current is not current's only target is from the initial position to final position. Okay, imagine current always optimizes its path. Current always optimizes. Current is eternally optimistic, eternally optimizing. मतलब it will always take the easiest path to go. ये बात याद रख लेना, current is very lazy, it always takes the easiest path. तो उस हिसाब से सोचो, ठीक है. Easiest path मतलब it will make sure that the current distribution is such that the potential difference will remain same. So eventually that is the main motto, no? Potential difference should be same. That is what current always does, optimizing. तो ये क्वेश्चन है दोस्तों, यहाँ पे क्या what all can be removed? This is a very good question. में कौन कौन से रेजिस्टेंसेस को हम निकाल सकते हैं, आई विल टेल यू नाउ. इट इज सिमेट्रिक अबाउट दिस डेफिनेटली. ऊपर जो भी है नीचे सेम है, तो जो भी परपेंडिकुलर टू दिस लाइन है वी कैन रिमूव देम. अगेन द स्टैंडर्ड ऑलवेज ये दोनों जो परपेंडिकुलर होते हैं ना उसको मोस्ट ऑफ द टाइम्स नेग्लेक्ट कर लेते हैं, बिकॉज इफ यू ऑब्जर्व सिमेट्री इट विल डेफिनेटली वर्क. सिंपल ना, यहाँ पे जो करंट फ्लो होगा वहां यहाँ पक्का वही करंट फ्लो होना, मतलब यहाँ पे कुछ करंट है ही नहीं. That's all that matters. Similarly here also whatever current is flowing, the same current should flow. तो यहाँ पे current फटाक, no current there. पर यहाँ पे जो current है वो flow करता ही रहेगा वैसे भी. So now we can simplify this. We will redraw this basically. We will redraw this to, अब ये दोनों series में हैं. This one and this one is in series with this whole thing. These both are series. ये दोनों series है. तो इसको काफी simplify कर सकते हैं. ऊपर 2R लिख दो, बीच में R, 2R, 2R और R, और नीचे फिर से 2R. तो वन थिंग में नो, अगर ये दोनों 2R है, ये भी R हो जाएगा, ये R है, तो टोटल नीचे 3R हो गया. तो वी हैव 2 2Rs फॉलोड बाय 1 3R. अंडरस्टूड. सो इसका इफेक्टिव रेजिस्टेंस कितना होगा 1 बाई 2R प्लस 1 बाई 2R 2 बाई 2R प्लस 1 बाई 3R होल इनवर्स हो गया 1 by R plus 1 by 3R whole inverse, which is equal to 3R by 4. Hence the option D. तो इसमें इसी क्वेश्चन को I will also solve it in a little different way. Just give me one page, guys. I'm going to solve this thing again. तो इसमें एक और ट्रिक बताता हूँ. I'll tell you one more trick now. When two points have equipotential, you can fold. It's like a plane of paper. You can equipotential points by folding. Like folding a paper. ठीक है, ये बहुत बढ़िया टेक्निक है. इट्स लाइक पेपर फोल्डिंग करके तुम जैसे सिमेट्री में होगा पेपर फोल्डिंग, यू कैन ऑल्सो जॉइन दिस पॉइंट एंड दिस पॉइंट बाय सिमेट्री. whichever when you have a line of symmetry you can just attack the whole thing up. All right, तो अब तब ये कैसा हो जाएगा, this whole thing will become like यहाँ पे दो रेजिस्टेंसेस आर, एवरीथिंग विल बिकम पैरेलल टू ईच अदर. इफ यू ऑब्जर्व, एवरीथिंग विल बिकम पैरेलल टू ईच अदर. तो इसको आई विल रीड्रॉ इट सेइंग, यहाँ पे r by 2 बोल दूंगा, r by 2, r by 2, r by 2, r by 2, r by 2. अच्छा ये दोनों तो चले गए, r and r. So this is what I can also draw it as. मतलब इसको थोड़ा और neatly draw कर दूँ. So I can symmetrify the whole thing and say I won't draw the lower part at all. If you observe, I won't draw the lower part at all. All right, this is r, this is r, r by 2, r by 2, r by 2, r by 2, r by 2. Again, about this point, it's symmetric, so this one will be removed again. So you can start solving this whole thing. You will get the same answer. ये दोनों का r हो गया और ये दोनों का 3r हो गया. So if you observe, इसका 1 by 3r plus 1 by r, which is equal to 3r by 4 हो गया. Understood? So you can also join two points which are equipotential across the plane. तो एक folding of paper type symmetry को ला सकते हो. Is it clear, guys? So if you are liking these techniques, definitely like दबा देना इसमें. Yes. Yes, hello Anjali, welcome. Yes, so this kind of techniques we can do multiple such things. All right, we can do multiple such techniques. Symmetry is a beautiful thing. All right, guys. तो इसमें effective resistance across AB निकालना है. तो इसमें how do we solve? ओके, इसमें करंट सिमेट्री का सोचेंगे. देखो यहाँ पे जो भी करंट है यहाँ से ये जाएगी, यहाँ से जो भी करंट है वहां से द सेम करंट विल कम. ऑलराइट, एंड वन मोर थिंग, यू नो, यहाँ से वॉट एवर करंट विल कम, इट विल बाउंस थ्रू दिस. Alright, because this side whatever current is coming, the same will happen, so you can remove this point. So here I am saying you can remove, like we discussed before, I will remove this junction. I can remove junction using symmetry. Remove a junction using symmetry. तो इस जंक्शन में जो चार है, बिकॉज आई नो दिस करंट विल कम इन एंड गो आउट, द सेम करंट विल गो आउट थ्रू दैट ऑल्सो. देयर इज नो एक्स्ट्रा करंट कमिंग इनटू दिस वायर बिकॉज ऑफ दिस. सो आई विल सिंप्लीफाई दिस टू, ये दोनों हो गया, और यहाँ पे दिस इज हाउ इट विल लुक. Well, now it became easy. This is 2r, this is r, this is r, this is 2r, and this is r. तो effective resistance कितना हो गया ऊपर वाला, r 2r by 3 plus r plus r. तो ये ऊपर वाला हो गया 8r by 3 और नीचे वाला हो गया 2r. सिंपल, 8r by 3 एंड नीचे हो गया 2r. तो इफेक्टिव रेजिस्टेंस कितना होगा, r1 r2 by r1 plus r2 which is 16r square, r by 3 by r1 plus r2 which will give me 14r. तो इसका कितना आ गया, 14r नहीं, 14 by 3. इससे आ गया 8r by 7 which is the answer, guys. So I hope you're understanding it. This is the kind of symmetry I would like you guys to understand and analyze and use it very thoroughly. Okay, you can remove a junction, you can join two things, you can cut something, you can totally remove resistances based on symmetry. इसमें एक और method भी कर सकते हैं. If you want to do the same method of understanding symmetry and breaking it through symmetry, we can also remove it across this point. If you observe, this symmetry is along this way. इस डायरेक्शन सिमेट्री से भी हम कर सकते हैं. वी विल डू दैट. वन मोमेंट गाइस, उसको मैं वर्टिकल सिमेट्री से भी कर दूंगा. आई विल डू इट यूजिंग दिस सिमेट्री. So in this symmetry, when I'm cutting this part, one thing you have to understand is when I'm cutting this kind of resistance, इसको r by 2 कर दो. Half on this side, half on that side. So now I will just combine it to make it like this. एक r है, एक r है, एक r by 2 है, एक r है. So this is how it will have. This will become double. 2 times the circuit will happen. So इसका effective resistance calculate कर दो. R by 2 and r, the effective resistance will be r by 3, and r by 3 and r will become 4r by 3. So you have one 4r by 3 in parallel with an r. So effective resistance कितना हुआ, 4r by 7. अब ये 2 साइड्स हो गया, तो 4r/7 into 2 which is equal to 8r/7. I hope this is clear. I cut this into r/2 and I joined it here. ठीक है, तो r/2 और r हो गए, ये r हो गया, these both together will become r/3, and that in series will this become 4r/3. Is it clear? I hope you are understanding what I'm saying. If you have any doubt, feel free to put it in the comment section so that we can have this discussion. All right. So यहाँ symmetry, you can either use vertical symmetry, you can use horizontal symmetry, you can remove any resistance which is perpendicular to the line of symmetry. You can play a lot, man. This is like, मतलब ये खेलने की जगह है. Is it clear? All right. All right. Now to this question. इस क्वेश्चन में I won't tell, इसमें आंसर तुझे दे दूंगा. I won't tell the answer. You guys, you do it. I'm going to give you 1 minute. ये इजी क्वेश्चन है, ये बहुत दिखने में बहुत, बस दिखने में महंगा. मानिए दिस क्वेश्चंस आर, they look big, but then the moment you start solving it, it's just small. Come on, guys. So this is a series of analysis, a full analysis of current electricity we will be having here. All right. This Ad Astra program which I launched here, इसमें पूरा current electricity का analysis मिल जाएगा. Okay. And one more thing I realized, lot of teachers on Unacademy are actually teaching what we are going through right now. Okay. Lot of teachers are actually currently doing electromagnetism also. So what I am thinking is, this is for 2021 guys. This entire course is specially for 2021 guys. So I am planning to launch something which is later part of your subjects, like semiconductors and nuclear physics. Very good. Sim 24. The correct answer is 4r/5. बहुत बढ़िया. तो मैं सोच रहा हूँ, by the way, कि I will start off nuclear physics after this, because those who are flowing in a flow, going in the flow is already going in the flow. So हमें, I want to help you a little extra by teaching you something which is ahead, so that when you're practicing again in the final part, you can do it well. All right. तो इसके बाद हम न्यूक्लियर फिजिक्स करेंगे. We won't go to electromagnetism, जो standard है. Everyone will go through that path only. So that is what I wanted to bring in, something new, something different. So I thought we will do nuclear physics after this. All right. तो yes, पहले करंट इलेक्ट्रिसिटी को फिनिश करेंगे, उसके बाद चलेंगे कहीं पे भी चलना है तो we will deal with everything with resistors and then let's go forward. तो इसमें यार सिंपल सी बात है, it is symmetric about this, it is symmetric about this, it is symmetric about anything you see. ठीक है, तो इसके अबाउट सिमेट्रिक है, तो फर्स्ट में इन दोनों को निकाल दूंगा. आई विल रिमूव दिस सर्क्यूट, आई विल रिमूव दिस सर्क्यूट. हो गया. ये तो सिंपल सीधा प्रीवियस क्वेश्चन टाइप ही हो गया ना ये तो ये सिंपल रीड्रॉ करने से क्या होगा, देयर इज वन 2r हियर, r हियर, 2r हियर एंड एन r हियर, और एकदम बीच में 2r भी है. सेम इसमें ऊपर नीचे सिमेट्री है. सो दिस इज व्हाट आई वांट यू गाइस टू अंडरस्टैंड. व्हेन देयर इज सिमेट्री बिटवीन अपर एंड लोअर पार्ट, एक बहुत बेहतरीन टेक्निक है, जस्ट हाफ एवरीथिंग. ओके, दिस एंटायर थिंग, व्हेन अपर एंड लोअर आर सेम, व्हेन अपर एंड लोअर आर सिमेट्रिक, r/2 मेथड्स. हाँ एग्जैक्टली. तो यहाँ पे भी हाफ कर दो, ये ऊपर नीचे इसको ज्वाइन कर दो, तो ये r/2 हो गया, r/2 हो गया, r/2 हो गया, r/2 हो गया. तो अब क्या हुआ, ऊपर एक r आ गया. नाउ वी विल हैव वन r, दिस बोथ टुगेदर आर r, एंड दिस r/2 एंड r टुगेदर मींस r/3. एक r/3 यहाँ पे हो गया और यहाँ पे 2r हो गया. ये कितना हुआ, 4r/3 एंड 2r. इफेक्टिव रेजिस्टेंस इज r1 r2 by r1 plus r2. r1 r2 हो गया 8r/3 by 8r²/3, r निकल जाएगा, by r1 plus r2 हो गया 10/3, which is 8r/10, which is equal to 4r/5. So that is it. Very good. That is the method which is wonderful actually. Hello Surinder S, welcome. लेकिन आंसर ये नहीं है, ठीक है, आंसर इज डी. तो सिमेट्री में if there is upper and lower symmetry, you just half all the resistances on top. होगी बात, ठीक है. This is a new technique, guys. I mean, I didn't see this coming. I thought, मतलब ये बता दूंगा, but I didn't see. When upper and symmetry, when upper and lower are symmetric, half the upper resistances, and done. Great job, great going, Sim24. This is a wonderful session. All right, चलो, very good job. Now let's go to the Wheatstone bridge. देख, मैं Wheatstone bridge को भी symmetry से solve करने का सोच रहा हूँ. All right. By symmetry, I want to solve Wheatstone bridge, and then by calculation, we will do it by two methods. One is by symmetry. Symmetry में देखने से समझ में आ जाना चाहिए. All right. Second thing is by calculation. Now, one thing you have to understand here is, यहाँ पे जो current जाएगा, same current should come here. यहाँ से जो current जाएगा, same current should go here also. Right. That is the whole concept, right? And these both should be at equipotential, which means the drop across this and drop across this should be same. So by symmetry, for me to remove this, this should be symmetric. Upar niche should be same. So what can I say? R1 by R2 should be equal to R3 by R4, because that is when symmetry will occur. This side will be same. That side will be same. समझ में आ रहा है ना? Basic symmetry along horizontal direction. इससे काम चल जाएगा. Got it? So this is the question. तो calculation wise देखेंगे. अगर if you want to solve by using calculations here, I want to solve this by using just calculations. तो इसमें क्या करूँगा? So I will say potential at A and B should be same. VA should be equal to VB. Only then I can remove R5. If I want to remove R5, VA should be equal to VB, which means the potential difference across this and potential difference across this should be same. IR1 should be equal to I2R2. Similarly, the same potential here also will be there. So we can also say IR3 is equal to I2R4. तो अगर इन दोनों को हम डिवाइड करेंगे, we will get I by I2 is equal to I2 by I is equal to R1 by R2, which is equal to R3 by R4. तो सीधा आ गया हमें रिलेशन. So everywhere Wheatstone bridge has the same condition, which is symmetry, where adjacent symmetry is equal to the same. It is symmetric about the starting and final points. बस वही है जो बोलता हूँ ना, वही है. It is symmetric about the starting point and finishing point. Finishing point के across these both should be having same ratio as initial point, these 2 points. About A, if you take starting point के about R1 by R2 ratio होगा current का, ending point के about R3 by R4 होगा ratio. समझ में आ रहा है ना? Ending point के about R3 by R4 ratio होना है, starting point के about R1 by R2 होना है. If these both are equal, then it is symmetric. I by A by 2. Yes, it is I by A by 2. जो ही वही लिख रहा था मैं. Yeah. Very good. I by A2. So this is about balanced Wheatstone bridge. इसमें एक छोटा सा simple सा problem है. इसमें I won't even give like I want to give 30 seconds, but यहाँ पे 30 seconds नहीं मिलते. But बोल दो बच्चों, come on. I need an answer within 15 seconds of this question. This is symmetry to its best. मतलब calculation थोड़ा बड़ा है, तो I guess 1 minute काफी है. It's perfect time. But then इसमें भी there is lot of symmetry I want you guys to understand. So I will tell you some nice one nice mathematical technique for it. So I will tell you one very nice mathematical technique with which you can solve this problem. Yes, very good, Anjali. A is the right answer. इसमें symmetry से मैं बता दूंगा. All right. So we know R1 by R2. Yes, time's up. Yes, A is the correct answer. Good job, guys. You know R1 by R2 is equal to 1 by 2, and similarly R3 by R4 is also equal to 1 by 2. So we can remove this totally. तो अब ऊपर कितना हो जाएगा? 18 हो जाएगा, नीचे 36 हो जाएगा. Effective resistance of this is 18 into 36 by 54. ये हो गया 3 times. ये हो गया So one more technique I want to tell you guys. Suppose you have R and NR in series in parallel. Effective resistance will be NR by N plus 1. Okay, remember this. So here also we have an 18 and 2 into 18 as in series. So effective value will be 18 into 2 by 3, which is 12. Okay, this is also one nice calculation technique which I'd like to share with you guys in this awesome session. All right. So great job. Let's go to the next question. Find the effective resistance across AC. This is also another very easy question. मैं बस symmetry में तुम लोगों को calculations देने का I'm trying to give you some calculations. All right. तो इसमें क्या करोगे? Let's solve this question. ये 5 है, 50 है. So this is a little different. And what is the reading in the galvanometer? My questions are: find effective and what is the reading in galvanometer? ये जो है galvanometer, it reads currents and potential differences. So what is the reading of galvanometer? तो यहाँ पे इसको basically what happened is they just opened the circuit into उल्टा direction. तो ये जो बाहर था इसको अंदर कर दिया और ये जो अंदर है इसको बाहर कर दिया. So if I actually split this circuit further, it will look like this. यहाँ से एक 5 पे जा रहा है, देखिए यहाँ पे एक 5 ohms पे जा रहा है, एक और 50 ohms पे जा रहा है, एंड आ रहा है वापस यहाँ 10 ohms से और यहाँ 100 ohms. Got it. So this way I can solve it, and this is where the galvanometer is. Now this is condition of a Wheatstone bit. So reading of galvanometer will be 0. Great job. Reading of the galvanometer will be 0. उसके बाद how much will the resistance be? If you observe, these both are in symmetry with this. Like ऊपर वाला resistance 150 हो गया, नीचे वाला 15 हो गया. तो effective resistance कितना होगा? NR by N plus 1. So it will become 10 into R, 10 into 15 by 11. ये हो गया 1. तो ये एक्चुअली आंसर है 150 by 11. So the answer is 150 by 11. It's not 110 by 11. It is 150 by 11. Understood? ये इसमें थोड़ा ऑप्शंस गलत है. तो effective resistance will be 150 by 11 आ रहा है ना इसमें. You can remove this. So 15 and 150 are in parallel. 1 by 15 plus 150 by 11 ही हो रहा है. Yes, exactly. This is so. Anjali, this question has been given and even the options have been wrong because of the exact thing that these both are not in series. If you observe carefully, these both are not in parallel with these both. These both are separate. If you observe carefully, this 5 and 50 are here and 110 are here. Getting it? So this is the main trick of this question, which so hence using that effective technique, the answer is 150 by 11. Understood? तो अंजलि, दिस इज अ स्टैंडर्ड मिस्टेक. दैट इज व्हाई आई एक्चुअली गिव द ऑप्शंस. मतलब मैं ऑप्शंस देना भूल गया लास्ट में. आई थिंक आई गिव ऑप्शंस बाय मिस्टेक, बट दैट आई गिव दिस क्वेश्चन सो दैट यू कैन अंडरस्टैंड दैट इट इज ओपनिंग ऑफ द सर्क्यूट, ओपनिंग अप ऑफ सर्क्यूट. तो इसको कैसे करोगे? यू जस्ट bring it outside and then solve accordingly. तो यहाँ पे across the positive volt there are two nodes going, both of them are 5 and 50. So you draw them separately like this, 5 and 50. Understood? So good job Sim 24, but Anjali, pay attention. This kind of options or this kind of questions will be very costly. In fact, this kind of questions are very important to analyze because now you'll put your head stably. नहीं तो सब क्वेश्चन ऐसे करते जाओगे ना तो it will end up becoming like you will not see the question completely. This is a good wake up call. Yeah, very good. अब सिमिलरली इसी टाइप का एक और क्वेश्चन कर दिया मैं. अब इसके अक्रॉस भी तुम लोग फाइंड आउट करो. इसका आंसर के लिए मैं आपको आई गिव यू 1 minute. अब यू ब्रेक इट डाउन. Very simple question this is, but you need to pay attention because if you keep shifting the positions A and B, you might Sometimes, yes, exactly. A is the right answer. Very good. You got it within 10 seconds, which is very pretty cool. So whenever you see this kind of questions, इसमें आधा minute काफी है. So whenever you see these kind of questions, imagine current is flowing here and here, it will be equal, and same current will come from here and here, right? Yes, very good. Same current which is going from this end to this end, the same current will come from this end to this end towards this point. Getting it? The current which flows through this will come back through this. So this resistance can be removed. Simple. Whenever you have some weird positioning of potential points, you can try to imagine current. That's a very easy technique. तो अब 2R हो गया, 2R and 2R parallel में है तो R हो गया. Voila. So now let's talk a little about Unacademy. That is about symmetry, guys. So today we will do a lot more topics. Abhi, this is all symmetry is about. So I hope you understood lot of. We did a lot of problems already symmetry के हिसाब से. So I hope this will help you a lot in calculating it. There are very complex resistances. तो वो actually basically इतना symmetry हो जाएगा कि तुम बहुत फटाफट लिख सकते हो. You can solve it within no time and get it. So that is why I did only very few problems. You can do a lot more problems on this. All right. Sorry, guys. So by the way, crack IIT-JEE with India's largest platform, which is Unacademy for sure. Get the Plus subscription and access live and recorded courses from India's best educators. All right. So what you get in the Plus subscription? You get daily live classes where you can chat with your educator and engage in discussions, ask your doubts, everything along with answering polls all while the class is going on. उसमें polls भी बहुत मस्त होते हैं. So teaching along with polls is a very effective technique there. All right. Not only that, you will have live tests and quizzes where you can evaluate your performance based on how you are giving the quiz. And as my motto says, when what do you say? A quiz a day keeps you ready for any for JEE any day. You have to write quizzes every day, which is why we have the daily quiz show. The show is at 8:30 today. This is for those guys. Everyone. अभी तक 10:30 होता था. It used to be 10:30 till now, but I've started 8:30 so that everyone can sleep a little early. All right. So live tests and quizzes you'll have every day. This will help you prepare, understand, and develop some techniques for exam. You have structured courses there. When you miss a course in college, generally, you will struggle to come back because the course is already done and you cannot see review it again. But with this structured courses, you have full review, full set of course, very properly structured, so that you can see that and analyze, study whenever you want. And you have unlimited access to all teachers from across the country. So it's a great deal. And like Joker always says, when you're good at something, never do it for free. Unacademy is charging this nominal charge of 38,500 for 1 year. 6 months ka course ka 28,000 hai. This is for all those guys who want to crack 2021. You can either take 6 months or 1 year. Not only that, use this code NSS1 to get extra 10% off, which makes the cost to 34,650. All right. And one more thing, ye 2 years ke subscription. This is for those guys who want to give 2022. 56,000 for 2 years. Use the code NSS1, you get it for 50,400. The cost of this is 23 rupees per day for physics, chemistry, and maths. So those who want to prepare regularly for IIT-JEE, those who want to crack IIT-JEE by doing regular hard work, this is a very good deal to go for it. You also have EMI options available. Not only that, the iconic subscription has been launched, which helps you with a personal coach, and your extra coach has been given to you. He will help you with your test analysis, help you plan your study, and much more. Not only that, you will also get all the benefits of Plus. The cost of this is 56,000 for 1 year. Using the code NSS1, you will get it for 50,400, which is pretty cool. You get a 6K off because of using the code NSS1. And you also have EMI options available here. For 2 years, it is 86K. ज़्यादा लग सकता है तो ये NSS1 code अपना लेना. You will get it for 77,000. And crack IIT-JEE sitting at home with the help of a mentor also. All right. So next thing we're going to discuss is Kirchhoff's law. We are going to discuss Kirchhoff's law, guys. This is a very important law. So we will discuss briefly about this. There are two laws given by Kirchhoff for determination of potential difference and current difference in branches of any complicated network. कुछ भी complicated network है, Kirchhoff's laws are there to help you with them. One is law of conservation of charge. Law of conservation of charge is a consequence of continuity equation. Exactly. तो मतलब यहाँ पे अगर कुछ फ्लो हो रहा है एक जगह से एक जगह तक कुछ current is flowing and gets split into two parts also. So by continuity, we can say that whichever current is coming through this will go through these both, right? Charges cannot get stuck here and they cannot start doing dharna. Charges are not like humans making traffic jams. So in short, there is the meaning is there is no traffic jam for current. ठीक है क्योंकि हमेशा करंट विल फ्लो whatever is coming in will flow out. There will be no one who will stop in the middle of the road talking on phone. Hello करके कोई no one will stop in the middle. Okay, they will just keep flowing. There is no signal also. Here करे outside signals में everyone will stop there. There will be accumulation of charge. Then it will go out. Signal is like a capacitor. ठीक है. Roads are like wires. Signal is a capacitor. It will store charge on one side, then release it. One shot attack से the current will flow. Got it? So that's a very nice analogy we just discovered, guys. Are like signals and current is like a free flowing road. ठीक है भाई जहाँ पे current is not even like human, so no one will stop. They'll just keep going. So whatever current is flowing inside will be equal to the current flowing outside. If you see this particular diagram, what are all the currents inside? I inside will be equal to I outside. Okay, thank you, Sim24. Whatever current is coming inside is current outside. What are coming inside? I2, I3, and I4. I2, I3, and I4 are coming inside, and they will be equal to the currents going outside, which are I1 plus I5. ये सब iPhones की तरह दिख रहे हैं ना I1, I2, I3, I4, I5. But yes, that is it. I2 plus I3 plus I4 will be equal to current flowing out. It can also say that the algebraic sum of current meeting at any junction in the circuit is 0. You can either say algebraic sum is 0 or you can say the sum of currents entering the junction is equal to sum of currents going out of the junction. This is awesome depiction and analytical approach by me. If you like this, just share this video. Okay, don't forget to share the video. So first Kirchhoff's law, sum of all currents leaving a node in any electrical network is always equal to 0. Okay, so we can also say in this particular question I2 plus I3 plus I1 is equal to 0. So this is a very cool description of it. और फटाफट इसका आंसर बता दो. I won't even give you time. What is the total current flowing in or out of D? What is the value of it? एक सिंपल सा एग्जाम्पल है. सिंपल सा एग्जाम्पल है. ये बहुत सिंपल है. देख what all currents are coming inside, what all currents are going outside. So let's take this is going outside by some x. I know it's coming in, but let's take it's going outside by x. So what can I say? 30 plus 120 will be equal to 180 plus x. So x कितना हुआ? Minus 30 हो गया. Which means the direction is opposite. So from this we can say the direction of current will be not this but this and will be equal to 30. Yes, exactly. So no, that is also not. You can also take that convention also. You can. So I did it using this method. Like I took current is coming in, going out here. I can just take current is coming in as positive, going out as negative. Yes, that is all we can take. Coming in is positive, going out is negative. No, that's all logically. So I can write plus 30 plus 120 plus minus 180 plus x is equal to 0. X is equal to minus 30, which means plus 30. No. Yes, x is equal to plus 30, which means current is coming in. That's it. Simple. All right. ये भी एक छोटा सा सिंपल सा क्वेश्चन है. तो इसमें फाइंड द वैल्यू ऑफ आई. What is the value of I? Tell this answer. So it's a very simple question. No, what are so just add of all values. What I will do is I will just keep adding or subtracting. एक करंट अंदर आ रहा है तो प्लस 0.2, एक करंट बाहर जा रहा है माइनस 0.4, एक करंट प्लस 0.6, एक माइनस 0.5, ये प्लस 0.7, माइनस आई इज इक्वल टू 0. तो आई कितना हुआ? माइनस ये दोनों माइनस 0.2 हो गया, ये प्लस 0.1 हो गया, ये प्लस 0.7 हो गया. आई विल बी इक्वल टू 0.6. Very good, great job, man. Awesome, awesome session, and I'm loving this. तो इसमें so now I will apply potentials. अब current calculation सब तो कर सकते हैं. Now I want you guys to understand, find the potential at A. इस point का potential कितना है? But this is one very interesting question. I want, this is a mixture of Kirchhoff's loop law and potential. Potential का definition से ये solve करेंगे. इसमें I1 ले लो. Let's say everything is flowing inside. So what can we say? The flow of current inside will be 30 minus. So इसमें पहले let's, before we crump it, यहाँ पे potential difference कितना है? Potential difference across this will be 30 minus A. I'll take the potential to be V. Okay, 30 minus V. और इन दोनों के बीच में पोटेंशियल 3 माइनस वी और इन दोनों के बीच में 5 माइनस वी, राइट? Now let's say current is flowing inward, everything is coming in. So what can I say? What will the current be? I'll call this 1, I'll call this side 2, I'll call this side 3. Current 1 will be equal to potential difference by resistance, right? It will be 30 minus V by 10. I2 will be 5 minus V by 5 and I3 will be 3 minus V by 7 and sum of all of them should be equal to 0. तो इस सब को ऐड कर दो, 0 कर दो, plus 5 minus V by 5 plus 3 minus V by 7 is equal to 0. थोड़ा ज़्यादा कॉम्प्लिकेट कर दिया मैं, बट चलो कोई नहीं. तो इन सबको इक्वेट कर दो, 3 plus 1 plus 3 by 7, सब इंडिविजुअल इंटीजर्स लिख दिया, minus V by 10 minus V by 5 minus V by 7 is equal to 0. तो V का 1 by 10 plus 1 by 5 plus 1 by 17 इसका कितना हो गया? 70 पे कर दो. 7 plus 14 plus 10 is equal to 4 plus 3 by 7 मतलब 31 by 7. तो इफ यू देख यहाँ पे भी 31 हो गया. V into 31 by 70 is equal to 31 by 7. तो V हो गया 10 volts. Got it? So this is how we solve it. I hope you understood it. If you understood it, just you smileys जो भी है, likes जो भी है, just keep sending them in the chat so that I can see and understand if you are able to understand it or not. तो समझ में आ गया ना? इसमें बस currents individually निकाल दिया using potentials and then I found the value of potential. Alright, so this is an awesome depiction. Okay, now इसका sum कर दो. This is a little lengthy question, so I'm going to give you a little more extra time. I will give you 1 minute to 1.5 minute to do this. तो इस क्वेश्चन को फटाफट जो सॉल्व करेगा वो मस्त रहेगा. तो इसमें जस्ट आई ऑल्सो गेव करंट्स अक्रॉस. तो the current is coming from somewhere, we don't know from where, but it is coming to a point which has a potential of 11 volts. और वहां से 2 ohm, there is a 2 ohm resistance there through which that extra current will flow and that current will get distributed across two ends. Now one end has potential 0, the other end has potential VB. Find the value. All right, yeah, thank you Sim24. तो इस ये क्वेश्चन बहुत मजेदार क्वेश्चन है. दिस इज अ क्वेश्चन आई मेड ऑन माई सेल्फ. दिस क्वेश्चन इज नेवर सीन बिफोर, आई गेस, मतलब फ्रॉम द बुक्स आई सॉ इट इज. रामेश, रमे नहीं रमे. This is not the right answer, man. B is not the correct answer. Oh, I think A, you wrote B, no? B is wrong. None of the options are matching here. चलो एक बार देखते हैं. हाँ, D मोस्टली करेक्ट आंसर होगा. लेट्स सी, लेट्स सॉल्व दिस प्रॉब्लम. नाइस ट्राई रामेश, गुड वन. लेट्स सॉल्व दिस प्रॉब्लम. यहाँ पे सिंपल है. यहाँ पे 2 coming in, which means total current coming in is 7, going in is 3. So here the going out will be 4 amps. यहाँ potential 11 है, so यहाँ potential क्या होगा? As we see, it's flowing down a resistance. So here it will become 3 volts. And what is the current flowing through this now? The current flowing through this will be 1, because here it is 3 volts and here it is 0 volts. The current here will be 1 amp and the current here will be 3 amps because current flowing is 4 amps. So this potential difference across this will be 11, 3 into 12, which is 12 volts. So 3 minus 12. So the answer is minus 9. All right. The answer is minus 9. I'm pretty sure that's why Sim24 stopped right now without solving. तो यहाँ पे 3 volts है और यहाँ 12 volts difference है. यहाँ पे 3 volts पे है और current is flowing like this 3 amps at 4 ohms. Means this drop is 12 volts, which means this value will be minus 9 volts. Yes, so that is the description, guys. So this is wonderful description. So Kirchhoff, the next thing we're going to discuss is Kirchhoff's voltage law. This is an awesome diagram which I've honestly not, I didn't do this there on online. Okay, this is an awesome depiction. Isme what it says is, in a loop, when you close the entire loop, the total summation of V in a closed loop is equal to 0. तो मतलब यही जो हम प्ले पेन का यूज लॉजिक करते हैं. लेट्स सी, सपोज यू आर गोइंग अप अ लैडर. Suppose this is the whole thing is a playpen. All right, you're going up a ladder, then going further higher, then taking a slide down, and then going through a cross, and then coming down again and reaching the original position. Will you be at a different level than the original initial position? You will always reach the same level in a closed loop, right? In a closed loop, you will always reach the same level as original. So which means the total potential difference, summation of all potential differences will be equal to 0. That is what Kirchhoff's voltage law means. The second law, or the loop rule, means that in any closed circuit, the algebraic sum of all potential differences and EMF is 0. Summation of E minus IR will be equal to 0. Okay, while moving from negative to positive terminal inside cell, EMF is taken as positive. Exactly. जैसे कि हम ऑलरेडी डिस्कस किए, नेगेटिव टू पॉजिटिव जाने के टाइम ऊपर जाएगा. while moving in direction of current, it is taken as potential drop because current will drop through that. Okay, and resistance and across resistance is taken as positive. This is based on law of conservation of energy. Yes, which is what we discussed, potential energy conservation. It is basically potential energy conservation because electrons को kinetic energy नहीं होगा, they go with constant speed, drift speed. So when current is going with constant speed, whatever energy, the total energy of the system will remain conserved. Hence this. तो इसका थोड़ा visual analysis एक बार let's analyze this in a little more step by step way. Let's take current is flowing in this entire thing to be I. यहाँ पे पूरा I current flow होता जाएगा. तो ठीक है. So from A to B, what will happen? From A to B, A to B will be equal to minus IR1 plus E1, right? E1 minus IR1, right? And potential from B to C will be how much? IR minus IR3, and potential from C to A will be minus E2 minus IR2. So the loop, using loop law, we can say sum of all these, sum of V A B B C C A is equal to 0. तो इसमें क्या लिख सकते हैं? E1 minus E2 minus I into R1 plus R2 plus R3 is equal to 0. Summation of E's plus summation of minus summation of IR's is equal to 0. This is what we derive. E1 minus E2 is equal to I into R1 plus R2 plus R3. So this is the meaning of Kirchhoff's loop law in a more analytical method. All right. So this is one derivation. तो फटाफट ये क्वेश्चन को हम सॉल्व कर लेंगे. फाइंड द करंट थ्रू ऑल रेजिस्टेंसेस. ठीक है. सो आई विल टेक दिस होल थिंग टू बी लूप 1 and I'll take this whole thing to be loop 2. तो इसी डायरेक्शन में ले लेंगे. This is loop 2. So I'll take in this current I1 is flowing, in this loop current I2 is flowing. Each individual loop I'll take separate. Okay. So now what can I say? 11 volts है यहाँ पे 5 ohm के across I1 is flowing, and across this 4 ohms I1 plus I2 is flowing. If you observe carefully, I1 plus I2 is flowing through that. This is loop 1 and this is loop 2. This is 14 volts, this is 10 volts and this is 11 volts. So in this loop, let me start solving it in this particular direction. ठीक है. पहले यहाँ से start करूँगा. प्लस 10 लूप 1 लिख दूंगा, प्लस 10 माइनस 4 इंटू I1 प्लस I2 माइनस 5I1 माइनस 11 इज इक्वल टू 0। और ये तो कुछ इक्वेशन आया। लूप 2 पे टेक दिस डायरेक्शन, प्लस 10 माइनस 4 इंटू I1 प्लस I2 माइनस 10I2 प्लस 14 इज इक्वल टू 0। ये दोनों इक्वेशंस आ गए, हम इन दोनों को वी हैव टू, इट्स अबाउट सॉल्विंग इक्वेशंस इन लूप लॉस, इट्स अबाउट जस्ट टेकिंग टू इक्वेशंस सॉल्विंग देम। So we have to solve for I1 and I2. Let's so इसमें क्या, just we'll have to solve this. So let's simplify them. What will we get? I'll send this to the other side. 10 minus 1. 1 will be equal to, I'll say leave this here only. Minus 1 is equal to 9I1 plus 5I2। और ये तो कुछ बढ़िया आंसर आ गया। और इसी इक्वेशन में क्या आएगा, 24 is equal to 4I1 plus 14I2। Wow, we got wonderful description, guys. This is how it will look. Let's simplify this। में कोई भी simplify करने का simple technique नहीं है। इसको into 4 करो, इसको into 9 करो, थोड़ा lengthy होगा, पर उन दोनों को subtract करो, इसको subtract कर देते हैं। इसमें क्या आ जाएगा, 4 will be equal to 36 minus 36 I1 minus 20 I2 and we will get 216 is equal to 36 I1 plus 126 I2। इन दोनों को ऐड कर दो, you get 220 is equal to, अब तो सेट ही है, ये -4 होगा ना, तो हाँ 212 विल बी इक्वल टू 106 I2, तो I2 हो गया 2, इसमें सब्स्टिट्यूट करो, I1 हो गया -1। All right, so we are getting the current in this loop is 2 amps and in this current is flowing in the opposite direction as 1 amp। ठीक है, तो इसमें it is flowing in the opposite direction with 1 amp। तो हाँ, ये 4 हो गया ना, ओह दिस इज 4, तो इंटू 5 कर दो। लेट्स सॉल्व दिस अगेन, कोई टेंशन नहीं, 9 ये तो सिंपल है, यही आंसर आएगा इवेंचुअली, तो हाँ वही है, इंटू 5 कर दो तो ये क्या हो जाएगा, इंटू 5 की जरूरत, अब तो इक्वेशन सिंपल हो जाएगा। इस इक्वेशन को सॉल्व करना है गाइस, -1 is equal to 9I1 plus 4I2 and this one, so I'll just multiply into 4 and into 9 now। Okay, I'll just subtract this, तो ये हो जाएगा प्लस, ये हो जाएगा माइनस, ये हो जाएगा माइनस, इंटू 4, so 4 is equal to 36 I1 minus 16 I2, और ये हो गया, हाँ अब तो हो गया 216 is equal to 36I minus 126 I2, माइनस की प्लस है, ये प्लस है, तो इन दोनों के ऐड कर दो, 220 इज इक्वल टू 110 I2, तो I2 हो गया 2, तो डबल मिस्टेक किया वहाँ पे, I1 हो गया -1, तो इसमें ये डायरेक्शन में है, इसमें ये डायरेक्शन में है, जो दोनों सही है। यस, वेरी गुड। नाउ जस्ट सॉल्व दिस क्वेश्चन। द वैल्यू ऑफ करंट थ्रू 12 वोल्ट्स इज द 12 वोल्ट बैटरी विच इज नथिंग बट I1, में I1 हमें कैलकुलेट करना है। So I'm using multiple kinds of boards just to make it more interesting, and if you are liking this, please hit the like button, share button, subscribe button, bell icon, everything possible। All right, इसमें ऊपर I1 है, यहाँ पे I2 है, यहाँ पे I3 है, तो इसमें कैसे सॉल्व करोगे? Let's take this loop first। One thing we know, I2 is equal to I1 is equal to I2 plus I3। We can write off I1 is equal to I2 plus I3 based on this diagram, whatever equations they are given we can write this। All right, so this is the first equation and then I will solve off for 3 equations। One thing is in this loop, इस loop को अगर हम देखेंगे तो यहाँ स्टार्ट होगा डी से, विल स्टार्ट फ्रॉम ए. ऑलराइट, तो ए से स्टार्ट करोगे लूप 1. आई कॉल दिस लूप 1. In loop 1, from A I am starting, there is a fall in potential here, so I will write minus 4I3. Alright, and यहाँ पे I2 उल्टा जा रहा है, तो I will write plus 3I2 plus 10 is equal to 0. फर्स्ट इक्वेशन में स्मॉल लिख दूंगा मैं, I1 plus I1 is equal to I2 plus I3. ये एक इक्वेशन है. ये दूसरा इक्वेशन हो गया, और इसमें लूप ले लो. इसमें स्टार्ट फ्रॉम B. I'll call that loop 2. इसमें क्या आएगा, तो instead of taking loop 2, I'll take the bigger loop, because bigger loop has smaller number of complicated equations. I'll call this loop 2. तो इसमें क्या आएगा, from B I'll start, from B to F there's nothing. Here there's minus 4I3 minus 2I1 plus 12 is equal to 0. ये आ गया तीसरा इक्वेशन. तो now we have three equations, three variables. In fact, you can take another equation also through this. You can call this loop 3 also. इससे भी solve हो जाएगा. But we found out we already have a decent solution here. तो इन दोनों को कैसे टैकल करें? So first I will find out, I will eliminate I3 in this. So I will just subtract both of them. तो इससे क्या हो जाएगा, 3I2 plus 2I1 is equal to 2. एक इक्वेशन आ गया. और I1 plus I2 is equal to I3, ये भी एक इक्वेशन आ गया. तो इसमें 3 times 2 times मल्टीप्लाई कर दो, कुछ तो हो सकता है. सब्ट्रैक्ट कर दो, तो यू विल गेट I2 is equal to 2 minus 2I3. ये एक हो गया. इसको ऊपर सब्स्टिट्यूट कर दो. इसमें समझ में आ रहा है ना गाइस? आई होप यू आर अंडरस्टैंडिंग दिस. जस्ट टेक लूप्स एंड स्टार्ट सॉल्विंग इक्वेशंस. चलो मैं आराम से और लूप्स लिख दूंगा. I will write all loops possible so that you can get full clarity before we solve the equation. Loop 2 is one. I hope this is clear. In loop 2, minus 4I3 minus 2I1 I1 plus 12 volts is equal to 0. So then I'll make loop 3 also. I'll write. So it is going minus 10. यहाँ से जाओ minus 10 minus 3 into I2 minus 2 into I1 प्लस 12 इज इक्वल टू 0. ये भी एक इक्वेशन आ गया. इससे हमें आया 3I2 प्लस 2I1 इज इक्वल टू 2. यही इक्वेशन हमें कल ही आ गया. ऑलराइट, so this is one equation, this is second equation, this is the third equation we got in terms of I2 and I3. Now I have to eliminate I3. That's all I need. I need to eliminate I3 in this. I3 can be written as I1 minus I2 na. This is the fourth equation. This I will substitute in this. What will I get if I substitute this in this equation 1? I will get minus 4I1 plus 4I2 plus 3I2 plus 10 is equal to 0. तो इसमें क्या हो गया, 7I2 4. I'll send it to the other side. 4I1 minus 7I2 is equal to 10. ये एक और इक्वेशन आ गया. अब इन दोनों को इक्वेट करो. 2I1 plus 3I2 is equal to 2. 4I1 minus 7I2 is equal to 10. इसको इंटू 2 कर दो, हो गया बात, और सब्ट्रैक्ट कर दो. तो यू विल गेट minus 7 minus 6 minus 13I2 is equal to 6. तो I2 हो गया 6 by 13. तो अब I1 कितना होगा, I2 हो गया 6 by 13. तो I1 होगा, I1 will be equal to 2 minus 18 by 13 by 2. तो ये कितना हुआ, 4 by 13. So this way you can solve all the values, and I3 will be I1 minus I2, which is minus, this is minus 2 by 13. Is it clear? I hope it is clear guys. थोड़ा lengthy equation है पर answers तो आ जाएंगे. And now next one more very important concept I'd like you to understand is delta to star. ये हम actually कल पढ़ेंगे. Tomorrow we will continue with this. We will continue with Kirchhoff's loops laws, and we will do this delta to star, star and delta transformations. So that's all for today guys. It's been a great session. Wonderful feedback from you guys also. Keep hitting the like buttons and keep hitting the smileys. So this is Let's Crack JEE in English for those of you guys who have trouble understanding English. This is specially for you guys. So since this is special, I hope you guys share it everywhere. All the guys who know friends who have trouble understanding Hindi. I know it's very tough for them to understand Hindi, especially in the South India. In South India, so I want you guys to share it among your friends so that those who have trouble understanding Hindi can listen to this channel and get help from it. So that's about it. Use the code NSS1. Don't forget to use it and hit the bell icon. Definitely in the comment section with any doubts you have. So great guys. Until next time, amigos. See you.